Hey there, folks. Just want to talk a little bit about the idea of the photoelectric effect. So if we look right here at our little photoelectric effect demonstrator here, you will notice that I have something that defines as intensity, meaning how strong the light is. You will notice here that I have a different settings for wavelength. So we have on the right-hand side infrared, and on the left-hand side, ultraviolet. You've heard of Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. So the idea is that metals in the photoelectric effect will only be able to eject electrons with a minimum frequency. So there's a specific frequency at which it will start to eject electrons. And so if we look here, we've got ourselves some sodium. Okay, and so what I'm going to do is I'm going to slowly reduce the wavelength, which is increasing the frequency. And you notice that I go to red light and nothing is happening. You're like, oh, neat, wow, fantastic. You got nothing going on here. Well, as we move a little bit further up, you will notice that the light is starting to change. Now we're getting more towards orange. Orange is doing nothing. Now remember, the frequency is increasing. The wavelength is decreasing. Okay, so the amount of energy is also increasing here. And as we go across and we keep going, now I get to yellow light and we still got nothing happening. Nada. And then we continue on. And then all of a sudden, oh, at blue light, it would appear, or maybe, what was that, a teal of some sort? No, maybe not. I don't know. Colombian blue, maybe. But you will notice that electrons are being ejected. And what that means is that we can see here, ladies and gentlemen, that these electrons are being ejected because we have reached the minimum threshold of energy. The light is the same amount, okay, in the sense that its intensity is the same. All right, I'm going to take a look here and show the photons that are happening. These are the packets of energy that are colliding. You will notice that they collide with the metal and eject electrons. But if I was to increase the amount of frequency, notice that we have more electrons that are being ejected. So we can go past that threshold in order to produce more electrons. And I can go ahead and stop it, change it so that it's just red light, and you'll notice that will not change. Now, we can change the intensity, and if you notice if I change the intensity, that means that there's just more photons there. But notice, as I increase, no matter how much photons I provide, it's still not ejecting electrons until I meet that minimum threshold. But you will notice with more photons means more electrons because we have more packets of energy that are able to make the electrons move. So, is there a relationship or not?